Maria Jurcevic. As the Education Associate for IOUG Headquarters, I would like to welcome you to today's webinar, Virtualizing Oracle 11G R2 RAC Database on Oracle VM Methods Tips. IOUG is pleased to continue our webinar programming with this informative and educational event. Please make note of our upcoming IOUG at Oracle Open World. IOUG's 45+ sessions are some of the highest rated sessions during the week, so take a look at the Open World Planner and schedule your time accordingly. Also make note of Collaborate 12, the IOUG Forum, taking place April 22nd to the 26th at the Mandalay Bay Convention Center in Las Vegas. Also, our call for speakers deadline is October 14th. Please visit www.ioug.org. We'll provide more information about these events at the conclusion of this webcast. Today's speakers are Kai Yu and Sar Mose. Kai Yu is a lead engineer and architect in Dell Oracle Solutions Engineering Lab and has worked with Oracle technology since 1995 as Senior DBA and Oracle Apps DBA. Kai's expertise areas: Oracle RAC, Oracle VM, Oracle eBusiness Suite, Linux, SAN storages, and network. Kai published many Oracle white papers and presented at various major Oracle conferences, such as Oracle Open World and Oracle Technology Network South America Tour and Collaborate and UK OUG. Kai served as the president of IOUG Oracle from 2009 to 2010, the RAC SIG, and awarded the Oracle ACE Director rank by Oracle Corporation in 2010, and selected as Oracle ACE Spotlight in June 2011. In April 2011, Kai won the 2011 OAUG Innovator of the Year Award. And our other presenter, Sar Mose, joined Oracle in 1993, has worked in support, and is now in RAC development. I would like to now welcome today's presenter, Kai.
Hello, good morning or good afternoon, depending on the location. My name is Kai Yu. Welcome to this IOUG Virtualization webinar. In next 30 minutes, Sarah and I will discuss the methods and the tips of virtualizing Oracle 11G R2 RAC database on Oracle VM. So, we are so fortunate to have Sarah Mose from Oracle to co-present with me. Sarah is the lead engineer in Oracle Corporation. He is the owner of a RAC VM template. So we are so fortunate to have him to talk about the Oracle RAC template. So I'm from Oracle Dell Oracle Engineering Lab. We are validated and certified validated Oracle solution, including the RAC database and the RAC, Oracle VM solution. So today we have a full agenda. So at first I will have an overview of Oracle VM technology and discuss the values of combining the RAC technology and the VM technology together, why we want to combine them, and how it looks like if we combine them together. Then we will discuss how to put them together, how to prepare the virtual infrastructure to run the RAC, and how to prepare virtual machine as a RAC node, and how to configure RAC database on VM. Then Sarah is going to show us how to use Oracle RAC VM template to deploy Oracle RAC on Oracle VM environment. This is a great way to simplify Oracle RAC deployment. This will cut Oracle RAC deployment time from days to 1 or 2 hours. So let's have a brief review of the benefit of Oracle VM and also the base components. So I'm not going to very deep, but I just have an overview. So Oracle VM is a software-based server virtualization solution. It provides several benefits. One is server partitioning and consolidation. This infrastructure allows us to run multiple virtual machines on a single physical server. We also can control the number of CPU and memory for each VM. And the second is this infrastructure gives us high availability. So VM, the virtual machine itself, can fail over or migrate from one physical machine to another physical machine. This completely removes the independence of a physical machine. So this provides the future great infrastructure and a cloud, because we want to have independency from the cloud infrastructure on the physical machine. And one last thing, and also a very important feature is the fast deployment and standardization. We can take advantage of Oracle VM template deployment to simplify the deployment, which Sarah is going to show us the example how to deploy most complicated infrastructure or Oracle RAC database. Oracle VM infrastructure includes several components. The first component is Oracle VM server. So Oracle VM server is based on the Xen hypervisor technology. It is this component that provides the capability to run multiple virtual machines on single physical server. So there are several virtual machines or domain. There's a special domain called DOM0. This domain provides management capability. It provides a network and a device and also the storage capability to the other domain. The other domain called DOM-U, which we can have many. This DOM-U is dedicated to run application. DOM0 itself does not run application. They only respond for all those management tasks. DOM-U is for application, but the tricky thing is DOM-U itself, all network and storage capability should go through DOM0. So the way we set up is we have to set up a storage network on the DOM0 first, then expose those resources to DOM-U. And the VM server pool is a concept of a group of a VM server together. All the VM server in the VM server pool has to share the storage, and this storage is the place we store the Oracle VM image. And the virtual machine can be migrated or fail over from one VM server to another VM server, as long as this VM server are in the same virtual server pool. The VM manager is a GUI interface, allow us to manage the entire infrastructure. Oracle VM 3.0 has a significant improvement on VM manager. So VM manager becomes a solid interface to manage the entire infrastructure. The VM agent is actually agent running on a VM server to communicate with the VM manager. Now let's take a look at why we want to combine the RAC with VM. One of the reasons is the server partition and consolidation. The advantage is we can have a multiple RAC node running on the same physical server in the development environment. If we run RAC on Oracle VM, each RAC node will be a virtual machine, not a physical machine. This Oracle gave us this called sub-capacity license advantage, which means is you only have to pay for the Oracle software license according to the number of virtual CPU allocated for this virtual machine. For example, if your physical machine has a 32-core CPU, but your RAC node, this specific RAC node only runs 8-core CPU, you only need to pay for 8-core CPU license for Oracle RAC software. there's a huge advantage to run RAC database on the virtual VM. And also another thing is the template-based deployment, which Sarah is going to show. We can use VM template, Oracle RAC VM template, to simplify to speed the RAC deployment. As we know, most DBA know will take days to deploy Oracle RAC database, but using VM template, we can cut this time to 1 or 2 hours. And Sarah is going to have detail for us. And also for production environment, let's look at this diagram. You can have a multiple RAC database running on single cluster, this set of a cluster. What happens is because, for example, in the physical server 2, the second instance of DB1 and the first instance of DB2, they are running share the same physical machine. But if this instance, the second instance of DB1 has no injection, they will crash the node. If this was if these two databases share a single physical machine, this instance will crash entire physical server. Then the DB2, the node 1 of DB2 will also be crashed. But since we use a VM, these two instances are running on separate virtual machine. The instance 2 of DB1 only crashes its own VM, and the DB2, instance 1 of DB2 still running fine. So that's a good advantage, provides high availability. Now let's take a look at what it looks like to run RAC on Oracle VM. So in this case, each RAC node will be virtual machine, will not be the physical machine. And underneath the virtual infrastructure will provide CPU, memory, network, and storage to a virtual machine. The virtual machine itself doesn't have any physical component. So the virtual machine will rely on all the underneath infrastructure, the infrastructure including the DOM0 and the VM server, and also the physical machine, and also entire storage. So to run a RAC. So all this resource will go through DOM0 and provide to the DOM-U. So this DOM-U is the actual RAC node. So if this was a physical machine, this physical machine has their own. They can access storage directly. They have their own network. So that would be much easier to configure. But if you put this on RAC, the deployment of to prepare the VM to run RAC, you have to prepare the network and also share storage on this layer first. Then you expose this to the virtual machine. So in the next few slides, we're going to explore how to do that. And the RAC deployment itself, once you have this virtual machine that has a shared storage and also have a network, I mean a public network and a private network. As long as you have this, the virtual machine itself just looks like just like a regular Linux. You have option to use a VM template to deploy, or you have option to manually deploy. It's up to you. But VM template will much simplify, will cut your deployment time. But the VM server itself, when you log in as DBA, most DBA, you probably won't tell this is virtual machine or physical machine. But as a DBA, you also need to know there's underneath infrastructure to support this. But as a system admin, you need to provide the entire configuration to run a virtual machine. So once initially submitted this presentation, this proposal to IOUG, Oracle VM 3.0 was not released. So, but now Oracle VM released just a few weeks ago. But actually, in our lab, we have been testing Oracle VM 3.0 for quite some time. We actually know this piece quite well. So I thought I need to take this presentation opportunity to share some of my Oracle VM 3.0 experience. So in last couple of weeks, we actually did some deployment, use the production release. So we know the features. So in last week, I actually changed modify a lot of presentation slides to replace with Oracle VM 3.0. So a lot of slides here are based on Oracle VM 3.0. I'm going to actually focus on the new feature of Oracle VM 3.0. So Oracle VM 3.0, basically the idea is not only the Oracle VM 3.0 not only will help you consolidate the infrastructure, also will help you to simplify the application deployment. That's something called application-driven virtualization. And what the Sarah is going to present later on is just an example. Is a very good example to show how to simplify the application deployment by taking advantage of Oracle VM infrastructure, also the template. And also Oracle VM 3.0 actually has dramatically improved the scalability. These are some of the numbers, like how many CPU you can look at yourself. So, and another big improvement of Oracle VM 3.0 is Oracle VM Manager and how to manage the infrastructure, how to configure this infrastructure. So really make sure that this is much easier to use. So in Oracle VM 2.2, there's a lot of configuration that has been done by manual script. But Oracle VM 3.0, they completely remove those requirements to do manual configuration. Everything can be done. Everything should be done through the VM Manager, including the underneath the infrastructure, network storage, also how to create VM, how to manage a VM, how to manage a VM server itself. So this new feature includes two major pieces. One is called centralized network management. Second piece is centralized storage management. So in rest of the presentation, I will spend some time to show how these two pieces work. So to create a VM infrastructure, there's an implementation task. That's outlined. Like you have to install VM server, VM manager, and also configure network and storage, then create VM, and also make sure the VM virtual machine has a proper network and storage. And this step is very common for even the VM that just run regular application. But for Oracle RAC, if you want to run Oracle RAC on VM, there's a specialty because there's two pieces. One is called the Oracle. Any Oracle RAC node require at least two network, public network and a private network, and also require shared storage. If you run Oracle regular application on Oracle VM, then you don't need these two pieces. So to run Oracle VM on RAC, to run RAC on Oracle VM, that make the infrastructure a little bit complicated. So VM server installation is not that difficult, and you just put a server and put a software installed. The one little piece that I want to show is when you get an Oracle VM server installed, after you log into Oracle VM, there's this message saying this is actually the VM server. This is actually the real screenshot. This VM server is called K4R710 OVS2. When you log in, there's a warning message saying you should not make any manual modification. So if you are familiar with Oracle VM 2.2, a lot of configuration work have to be done on a VM server level. But Oracle VM 3.0, they completely remove that, and they give you a warning, and they want you to not do anything on a VM server as long as you once you finish installation, and let Oracle VM Manager handle everything. So now you have to install Oracle VM Manager, and the VM Manager installation is you can actually reference the installation manual. It's quite straightforward. After you install that, you have to connect these two. So and also you also need to discover the VM server from VM Manager. And you added that VM server to a VM server pool. So that was the concept. You can read this. But the thing I wanna focus on is how you design the virtual infrastructure that for Oracle RAC, and that's something you don't see from regular document, because the document is designed like you run Oracle VM for application, not really spend so much time on how much what do you have to do for RAC. So this is the infrastructure designed to run RAC. This is based on Oracle VM 2.2. So you have, on a VM server level, you have this storage. Then you will build something called a bridge, so that the guest VM can access. So the guest VM requires two virtual network, but the guest VM itself, virtual machine itself, doesn't have physical network. The physical network truly rely on the bridge that is built on top of the physical network. So that's and also the storage thing. So this is 2.2. Let's look at 3.0. 3.0 is very much similar, but in Oracle VM 3.0 they actually have a little bit different concept. The one concept is the separated network. So you can see here, there are three different networks: private network, public network. These two are not new, because when you run RAC, you need these two networks. We're going to expose this network through bridge to guest VM. But this one piece of network, I put this red color called management. I just put M. It's a management network. Management network is really for Oracle VM manager to talk to the VM server. We also put another piece of network called a cluster heartbeat. So as we know, the Oracle VM uses OCFS2 cluster file system to establish the storage. That's this piece. The shared storage is built on top of OCFS2 cluster file system. That's where you actually store the VM, the virtual machine image. So you need a cluster heartbeat network to support the OCFS2 cluster file system. So we combine all of this network into one piece, just to simplify. You also, if you have more network port, you can separate too. There's another piece called a migration. So if you want to migrate this guest VM from here to here, you also require network to transfer the VM image, the data from one VM server to another VM server, so called a network for migration. So we have three networks combined together: manager network and a cluster heartbeat and a migration. We combine this into one, and this network are not needed for guest VM. So that's why we don't have a bridge. In the public network, these two public network and the private network, they all have a bridge to extend it to guest VM. So that's how. Another piece is called storage. We have this piece of storage for network, and we have a current disk to OCFS cluster file system. This is actually how network designed. So this is the mapping from logical network to actual port in the physical machine. This is how network. Then, so you need to know this concept. Then you can navigate it. You go to VM Manager to actually create this mapping. So this is the actual screenshot of VM Manager. They show three networks. Only these two networks has this responsibility called for the virtual machine, so which means the virtual machine can use these two networks. Then this screenshot for this network, how this logical network map to a physical network. This is actually port. This is actually port 3. You see this private network is mapped to port 3, which is this. Oh, yeah, this is different screenshot. So match to this. So you can configure entire network mapping, or you can create physical network and create a mapping from the logical network to the physical network on the VM or virtual machine. Next piece is the storage. So Oracle VM 2.2, you have to do all the manual configuration of the storage by yourself. But Oracle VM 3.0 allow you they will automate this entire storage configuration. What they do is Oracle VM Manager has this called a Storage Connect plugin. This Storage Connect plugin can identify the shared storage by themselves, so you don't have to configure. So this is actually a screenshot shown in the VM Manager. We actually can see this Dell component shared storage. So you list all the storage. We're going to use this for the VM repository. Now we can use this piece. The VM repo is for the shared storage, the storage repository to store the VM image. This is for class Heartbeat. Rest of this we can use as RAC database. So this rest of volume is going to be used for RAC database. And the storage repository is very important because this is a place we store the Oracle VM image, including local disk. So Oracle VM 2.2 to configure this piece is all the manual work, and it's very complicated. But Oracle VM 3.0, you can come here, just click a couple. You can use this GUI, make some couple click. You can create this VM storage repository. So this actually shows the storage repository built on shared storage. Then let's take a look at the structure of the storage repository. In this storage repository, you can store many different things. You can store virtual disk. You actually can store the virtual machine image. So all the virtual machine images are stored in this, and also in configuration stored in this virtual machine directory. You also can store the assembly, which is the combination of the multiple VM together. And you also can use a template. So you can go to the Oracle eDelivery website to download template and store it here. And for RAC database, Oracle recommends to put a RAC database on the physical disk instead of on a virtual disk, because the virtual disk is actually live on the OCFS2 class file system, and you will have some performance overhead. So this is how you actually can create a virtual disk on the shell volume. Now on this virtual server pool, I have this all this storage. With this, we have the entire infrastructure. We have network. We also have a storage. Now we can create a guest VM. So when you create a guest VM, especially for Oracle RAC, you have to think about two things. One is the network. Second is shared storage, because this is very important for RAC. So as we mentioned, the Oracle VM itself, the virtual machine itself is a virtual machine. The machine itself doesn't have any physical component, including the physical network. So in Linux, when you install Linux on any physical machine, the Linux will identify the network call on the server and create the network interface for that. That's a physical network card, but a virtual machine doesn't have physical network card. So you need to manually create a virtual network interface. So before you create a VM, the VM Manager has this feature to allow you to create a virtual network interface. So then you create it, for example, for this virtual machine, I created two network interfaces. This one is assigned to public. This one is assigned to private, which means this virtual network card will connect to a bridge to public network, which we just created on a physical level. And this network card, virtual network card, will have a connection to the bridge that connects to the private network. So this is a screenshot to create a virtual machine. It's not difficult once we have a template. Then the thing you need to take a look at is there are two. You need to specify the network interface. Another component is the storage. So as we just mentioned, we just created two pieces of a physical network, physical storage, a physical disk called data 1, data 2. Then we gave this to, this is actually a screenshot. We gave this to guest VM. Now this guest VM has three pieces of storage. These two, these two are local storage. They all live in the virtual disk because they all stored in the repository OCFS class file system. We can use this as a local disk. This is basically OS disk. This is a local disk. For example, you want to put Oracle Home on it, or you want to put OCFS Classwell Home. This is a two-piece for your database. You can use this to create an ASM disk. You can put an ASM disk group on that. So these are dedicated for your RAC database. That's a special for RAC, for you deploy RAC on local VM. If your VM is just for the application, you don't have to create this piece. This is a network. You have two pieces of network, public network and a private network. So this is actually the actual screenshot of the console. You can, from Oracle VM Manager, you can log into the virtual machine console. So this virtual machine console, this command show you have two network. E0 is for public, E1 is for private. As we mentioned here, the private, this is E01, is mapping to private. The private, we know before, the private network is based on two physical network bonding. So you will see that this network card is actually corresponding, this virtual network is actually supported by two physical network bound together. This meets our requirement to have a bound network for private interconnect. Then this shows the storage. So if this machine was on physical machine, you will see this disk, and each of these are actually physical disk. But this one is virtual disk. But as long as you see this, you know you have shared storage, especially this piece. SVDB, SVDC, these two are the shared storage for you to put a database on them. This 1 gig is for local disk, and the XVDA is the OS disk. That's how you divide it. XDA, these two for shared disk for database. This is local disk for you to put Oracle Home. So that's concluded the virtual infrastructure configuration. Now I turn this to Sarah. Sarah is going to show us how to use the Oracle VM template to deploy Oracle RAC. Thank you.
Thank you, Kai. This is our from Oracle working in RAC development. Basically, we have RAC templates available since last year on all these versions. Some of them are posted on eDelivery, and some of them are only available on My Oracle Support. So you can see 11.1072, 11.1076, 11.2012, 11.2014, 11.2020, and 11.2022. And future versions will be coming out as the software is released by Oracle. So there is a My Support note that describes all of them. The number of the note is 1185244.1, 1185244.1, You can see that on My Oracle Support. That'll give you the version numbers and all the details. The templates are basically comprised of two files. We release an operating system file and the Oracle software file. So there's basically two disks that you get from when you download. The Oracle part has the entire Oracle software. The OS part has currently OEL 5, update 4, 5, or 6, depending on which version. And you can mix and match. So if you wanted to get a U4 with a newer version of the software, then you can mix and match the OS and the Oracle disk. As you'll see, the entire install is completely automated with the bare minimum of questions asked. So basically, only the network we ask for, because the network will be different based on which customer is installing it. So the templates are available on 32 and 64 bits, right? We release them as sparse files, so even though the disk files look like it's, I don't know, 15 gigs or 20 gigs, the actual consumed space is a lot less than that, and the rest is just zeros. So if you do a ls-s, you'll see the actual consumption of the sparse file. So that's one thing to watch for. The templates come as a zip file. Inside them are TGZ files that preserve the sparseness of the files. And then you have a PDF, a README file. Please, go through the PDFs, and that'll give you all the frequently asked questions and the steps to deploy. So the features of the templates, the 11.1 only supports a two-node manual, two-node installation, completely automated, but the add node is all done manually. So, traditional add node would entail there. In 11.2, we made drastic changes to the build engine, and basically it's using one command engine similar to the one used in the Exadata deployment. And so basically that allows you end node build as well as fully automated remove and add node and or instances. The templates also work, both of them. They all work on OVM3 unchanged, so you don't need to do anything special. Just map the bridge names to the bridges on OVM3, because on OVM2 they were like ZenBR 0 and 1. On OVM3 they're called differently, so you just need to map those and that's it. So the standard 11.2 standard two-node interview works the same as it was in 11.1. I'll probably try to show you that if we have time. And then there is also an end node fully automated build directly from DOM0. So you don't need to log into any VM to build any number of clusters of any size. So I bet you it'll take you longer to collect the IP addresses that you can use than to actually run the build. You'll see how quickly that runs through. We run as root, but you can also run it as Oracle or the grid user. As I said, fully automated, add, remove nodes or instances, any number in one command. So you can add 10 nodes or remove 5 nodes all with a single command. Also, the commands could be concatenated, so one after the other. So you can just basically run loops of operations to the environment. It'll process them, and if there's any failure, it'll stop. But traditionally, there should not be any failures. It just works like a machine. We are testing it here around the clock, so there should be no failures at your when you actually use them. The only failures you might see is before the check phase, where basically the build is broken down into steps, and so there's a step that checks and validates, like, for example, that the IP address is not used by any other device on the network, or that the IP addresses are actually digits and not characters, things like that. So it's just, if this validation passes, then the build will succeed. This is also well tested on OEL 6, and whenever that is announced, then it'll work just fine. And then supports role separation and non-role separation. And we have basically we send out the templates, one copy of the templates with two documents, one to deploy in a test environment and one to deploy in a production environment. You use the same bit to deploy, but basically it's just a production or test. Just follow the different README and it'll guide you through. The main difference is that in the production you have to use the physical devices rather than files stored on a shared disk. Okay. And then so the procedure would be simply to download the requested template 3264 on, or that, or 11.1 or 11.2, then register it with the manager, create 2 or however many VMs you need, and that's up to here. It's standard OVM, operations. And then you create shared disks using the manager if this is a non-production. If it's a production deployment, you'd use the physical disks on DOM0. And on OVM2, you'd have to edit the file. On OVM3, this is all automated as well. Then you'd boot the VMs, and then you basically run the one command to configure and build a cluster. So when you boot the VMs, you have two options. Either you're going to do an n-node build, or you're going to do the traditional 2-node interview. Most people will probably start with the 2-node, and that's what I recommend. But once you get the hang of it, it's really cool to create a farm of clusters, and we have various customers doing that, providing clusters to their internal systems so they can use the fully automated from DOM0 and just basically allocate IP address namespaces and then create as many clusters as they need. So this is the 2-node interview. Let me break down here and show you how it works. Okay, so I'm here on a DOM0. This is version 2, but it works the same in version 3. For the sake of simplicity, I'm showing you everything on DOM0, but really this should be running from the manager. Okay, so as you can see, I do an XM list, and there's no VMs running, only DOM0. At this point, I can start one VM, and basically it's XM create and the VM name. It's going to boot the VM, and then it's going to come to an interview, and we'll see that in a second. So while this guy's running, let me start the second VM. Okay, same command, just a different VM, and now they're both basically booting up, and in a minute, both of them will ask us the same question. Is this the first node in the cluster? Okay, so it's up to you to decide which one is the first node. Basically, the VMs are shipped with no personality. So there's no, nothing is configured. We don't, have any IP address or name or anything like that. So you basically have to, set that up yourself. So when they boot, there's no network, right? So you'd have to kind of define that. And what we do is we give you a very simple interview screen that is filled only on one node, okay? So here we go. It says, is this the first node in the cluster? On this side, I'm going to say no. And this VM is going to dot away and kind of wait for the interview to finish on node 1, as you can see here, right? And okay, so we're asked the same question here on the second node. And if we look at the first node, well, the second node here, it's still dotting away, waiting for the interview to finish. Here I'm going to say yes, this is the first node, and I'm presented with the screen. For sake of simplicity, I've already entered the data here, but basically you can enter any data that you want. It's going to validate it using regular expressions, so if you have any typos or things like that, it's not going to let you go through. If you have duplicate IP addresses, it's going to catch that. So it's basically validating all this input right away on this screen, so you can't type, junk data. Here you can set your DNS IP. In my case, I'm not using one, so that's fine. And then this is the common area where we ask for the Ethernet names and subnet masks, default gateway, as well as the domain name. So the final questions are related to the cluster name, and the scan name and IP address. Okay, so the reason we're asking for the IP address is because there was no DNS IP specified. If in a DNS IP specified, then we wouldn't query the DNS, the scan IP, because we can just query it from DNS. So then, is this okay? I say yes. And are you sure about that? I'm going to just show you the dots here on that side. And as soon as I hit enter on this screen, both VMs are going to configure their network. And there's some magic going on here, basically, because there's no network. How can they communicate the information one to another? As you can see, this is like happening in real time. Basically, what's happening is both of them, I mean, the first node basically stamped the network configuration to the shared disk. And as soon as that was done, the second node read that configuration from the shared disk, and then both of them configured their network. So this is pretty nice. And at this point, we can log into the system and basically go here. And there is this, I mean, here we can now make changes if we wanted to the build specifications. But if we don't want to make any changes, then all we need to do is just run build cluster. That's it. So it's saying, are you sure this is gonna, this is what you want to do? And I say yes, and the build starts, and it'll succeed. In this case, this is a very slow machine, one of our development boxes, so it's undersized and all that. It's going to take about 40 minutes, right? We'll come back to this every once in a while, but you can see that it's starting the one command engine, it's setting up SSH on all the nodes, and just continues to run through the build, and prints out the specification of the environment, like what are the nodes that it's going to build on. And again, the same build works on any number of nodes, 60 nodes, 20 nodes, or 2 nodes, or even 1 node. So let me go back to the slides for a minute and describe the screen again. Here we can see on the top side we have the specific node interview, and on the bottom, on the middle, we have the global specification. On the bottom, the cluster details. So once you log in, you basically run the build cluster, which will build the cluster as specified in the 2 files, the netconfig.ini, which basically is the file that holds all the network information, and the params.ini, which basically holds the defaults for like the database name, the UID of the user, the username, and all sorts of things like that you can still tailor to your environment. We see through testing, we see 2 node on newer hardware, basically running in about 18 minutes end-to-end, including DBCA. 4 node about 23 minutes, and this entire procedure is I/O bound. So it's not going to help much if you add more CPU or memory. It's going to be just I/O bound. So if your disks are fast, that's going to help a lot. Okay, so these are the 2 files that we're talking to you about. There's basically 6 items per node. So there's public, private, and VIP, and there is IP and name for each one of those. So that's 6 elements for each node. Then there's the NIC information, the cluster name, and this stuff is mostly fixed data. It doesn't change much unless you add more nodes and so on. The other parameter file is basically has all the database name, usernames, and so on. So if you wanted to build more nodes, all you have to do is basically add 6 lines to this network configuration file. So as you can see, node 2 is called test 171, the IP address, the the private IP, and that's how you add the node. So you'd have to type in this information. We cannot guess that. You'd have to supply that, name and IP addresses. Once you have that, then we just run a single command that says add node and the node name. That's all it is. It's very, very simple. It'll do all the necessary operations on the back end to update and the inventory and all that. So this is describing running the automated build from DOM0. Basically, we're using the same tricks here. And what we do is we don't know how many nodes there are going to be, right? So instead of communicating or logging into each one and setting up the network, right, we're automating the network setup. And the way we do that is we stamp the shared disk, okay? We stamp the shared disk with the netconfig file, and then when they boot, as you can see, we're passing an argument via the extra line here. So basically, when you say xm create, it actually starts up the VM. It doesn't really create the VM, it starts it up. So xm create will start up the VM, and then extra, whatever you put on the extra, will pass to the kernel boot line, and that will be processed by the first boot of the VM. So on node 1, we'll specify -n1, and on node 2, we'll specify -n2, meaning it's node number 2. The -r means to read the file from disk. And basically, I can show you this real quick here. This is the 2-node build. You can see it's going through the procedure of installing RAC and configuring it. We can see it's running root CRS. There's completely nothing you need to do here. You just look at the log and enjoy it. All the commands are spooled out to the screen, so you can copy and paste those and run them manually if you wanted to. So this is the second. This is the automated build. I have a file here called demo 2nodes. Let me look inside that file. And basically, we see the same thing as in the slide. xm create the VM name, and then extra, and then this is just the console connection, and then this is where we pass the arguments to the kernel boot line. So we basically say read, and then -n1 and -b. So that will be the build node. The first one will be the build node, and the second one will be the second node. I mean, but you can have as many nodes here as you want. The reason I have a sleep here is so that it'll wait and start the second VM only after some time, so that we can see how the build node acts in a special way, in that it waits for all the other nodes to come online before it starts the build. So if I didn't have the sleep there, then it'll kick off the build right away, and it still looks cool, but it's more cool to see that it actually waits for all the members to join, because it actually knows who needs to join, right? So I started the VM. The VM ID is 1880. So let me go and connect to it. Okay. So, and then we'll look at, it's going to start the second VM shortly. But here what we'll see is that here, the second VM is starting right now. But the first VM has a head start, right? So it's going to come up, it's going to set up its network, and then it's going to say, hey, I'm waiting for all the other members, in this case only 2, to be online. And so it's going to wait until the second node comes online, and then it's going to kick off the build. So here it is. It's saying I'm reading the configuration file from this disk and writing it to the file system. I'm setting up my network, right? And right after that, it says, there is an automated build requested, and one node is not available, right? because of the sleep. I put the sleep there so that we could actually see this message. And as soon as the second node comes online, let's see if we can. All right, so this is the second node. It's now coming up, and it's going to do the same thing. It's going to configure its network. And so as soon as the network is done, the first node is going to detect that and kick off the build. So basically, it's going to wait like that for like about 5 minutes to give time for all the VMs. I mean, they could be a 20-node cluster or whatever, and so we're just waiting there. So in case you don't get it working the first time around, you'll just experiment with it, go through the PDF, and you'll see it's pretty simple. Okay, so that's it. So as soon as that second node configured, it says auto build cluster detected. All nodes are accepting SSH, and it'll start the build and give you the PID and all that of the build, right? So here we go. We have the build, and here is the the log file. So if you had more nodes, it'll just wait for all of them to come online. And let me just show you. Let me just tail that log file, right? And we can see that it's pretty much setting up the SSH and so on. And so it's basically running through the same operations that this thing ran through. But the difference is that here, I didn't even need to log into the VM. The only reason I logged into the console and such is just to show you what's going on. But you can pretty much kick this off and forget about it. So that's it. That's the yellow screen again. This is the first build that we started. It's going through the build, and it'll just kick off. It'll just keep running until it's all done. I want to show you. This is just how the build finishes. This is a different cluster that when it finishes, it just says these are the nodes, and 4-node cluster, and this is a 2-node cluster. If you wanted to do an add remove node, you'd type something like this, okay, and then you'd type in the node number or node name. So this is going to fail, right? Because it's wrong syntax. It just basically tells you that you need to specify the -n for the node number. So the node. So that as soon as I say that remove node, it's going to do. It's going to basically remove the node from the cluster. So that's how easy it is. This is all logged, and so you can pretty much run this kind of commands yourself. And if you wanted to add the node back, you just add node. All right. And then finally, be familiar with the OTN pages. We have a page placeholder for the RAC OVM templates. This is the 11.2 page. It has all the links to all that. The e-delivery is going to take you to this page to download, and this is the support node I was telling you about. Sorry, this is the support node I was telling you about that basically shows that shows all the released versions and the features and so on. So you can get all the links here on how to download the various things, because in my Oracle support, you'd have to kind of find the patch number for the exact release that you want. So I think I can skip through. The rest of it included some of the slides for reference, so you can look at them later on. But basically, you'll see, the banner of the one command, the timing. It's going to print exactly how long each operation took, and then this is, the full command lines if you needed it. Most likely, most users will just do a build cluster, and if they wanted to change anything, they could do a clean and rebuild it. So, but as you grow, you can kind of expand on that. So this is the syntax for the add remove I was kind of showing you, and you can do. You can see you can put a comma between the nodes and basically specify as many nodes as you want. You can also put a comma between the step name. So it would be add node, comma, remove node, comma, add node. So it'll iterate in the loop, remove and adding the nodes. There's also the do all that basically runs commands on all the nodes in the cluster. And I think we're running out of time, so I kind of like to open the lines for questions, I think. So.
Hi, Sar. Actually, I mean, if you want to wrap up your presentation, we will not have time to respond to questions. Is there anything left that you need to cover?
No, that's
okay.
Pretty much it for me.
Okay, great. So I do want to thank the both of you. As I said, we've run out of time to respond to questions verbally, but Kai and Sar will be able to still respond to the questions via email by forwarding their responses to IOUG, and therefore we will respond to the appropriate people. So we do appreciate all of your questions that have come in. I do also, before we wrap up here, I do want to remind all of you that we do have IOUG will be it has an upcoming conference next year in 2012, and so please make sure to take a look at that. April 22nd next year, Collaborate 12 in Las Vegas at the Mandalay Bay Convention Center. And also make note of IOUG at Oracle Open World, where IOUG's 45-plus sessions are some of the highest rated sessions during the week, so take a look at the Open World Planner and schedule your time accordingly. And also make note of our call for speakers. Deadline is October 14th, and status notifications the week of December 6th. Technical white papers are due March 1st, and presentations are due March 1st, 2012. And again, thank you, and we still have our next webinar coming up on next week, so please take a look at those dates, as the dates right now have shifted. We do want to also thank Kai and thank Sar again for presenting today, and thank you everyone online for attending the event today. So we thank you in advance for any of your feedback. If you could please fill out the survey once this webcast is complete. This feature will be available on the IOUG website at www.ioug.org. And thank you again for attending today's webinar. Have a great day.